Okay, guys, so H-17 on Delta Math, which is where your practice is. Numbers 1 and number 3 that I'm about to do are asking similar questions. Number 1 is when is a particle speeding up or the speed is increasing, and the other one is when is the speed of a particle decreasing. There's a way to do it without a calculator, and there's a way to do it with a calculator. On the AP test, there's 2 sections, one with a calculator, one without, so you need to know how to do it both ways. So on Delta Math, I'm not going to be specific, or it's not. I didn't make up the problems, but they're not going to specifically say to use a calculator or not. So you just need to, use your judgment and, practice a nice balance with and without the calculator. If you really want to do something, maybe that I would do, what I would do if I were you is do it without a calculator and then check it, verify it with a calculator. That's another way, but you want to have fluency with both methods. So number 1, let's do this. This will be the no calculator method. No calculator method. So we've got a particle. A particle moves along the x-axis so that at time greater than or equal to 0, its position is given by this function. Determine all intervals when the speed of the particle is increasing. And I did mention before in the last video, the speed increasing is the same as the particle speeding up. All right, so that's where this table comes in. Speeding up, if the particle speeding up, that means that velocity and acceleration are either both positive or both negative. So they need to have the same sign. So whenever you're trying to think about the signs of a derivative, whether a derivative is positive or negative on a certain interval, you do an interval sign test, okay? So, so velocity. So I'll go v of t, that's the first derivative, negative 20 plus 60 t. Okay, and then I'm going to factor it to find the critical numbers and to get ready for my sign tests. T squared minus 3. Okay, now guys, you're probably not used to this from the past, but usually like if this 3 was a 4 or a 9 or a 16, you would do a difference of 2 squares. You can do a difference of 2 squares no matter what the binomial is. Okay, so you just have to take the square root of the first term and then the square root of the second term, and then have one binomial with plus, one binomial with minus. So because we're going to be doing a sign test, it's really nice to have everything factored. So this is going to be t minus radical 3, t plus radical 3. Now, if you didn't know to do that, then to find the critical number so the critical number for this factor is going to give us 0 as a critical number. But then for this factor, you'd have to set it equal to 0, add the 3 over, take the square root plus or minus. Okay, so you're going to get plus or minus radical 3 either way. But when we're checking the signs, positive or negative, for me, this is a better situation. All right, so now I need an interval test. Now here's the thing, guys. I'm not going to do an entire number line because time is greater than or equal to 0 only. So I'll just start, so this will be 0, and then I'll just go like this, okay? And so our critical numbers are when velocity is 0. So you ask yourself, when is this thing 0? Well, for this term, it's 0. Actually, let me go like this. I'll group that as a term. Okay, for this term, the critical number we get is 0. Well, that's the end point anyway of the interval. For this term, we get radical 3 as a critical number. For this term, we get negative radical 3 as a critical number. That's not even on this number line. Okay, so we're only using the critical number radical 3. Okay? Now I'm going to pick a little number in here, like 1, and then I'll pick any number like after here, so I'll pick like 2. 2 would even work, yeah. Or, yeah, 2 is fine. All right, so if you plug 1 in for the t's, here we get a negative. Here we get a negative because 1 is less than negative, well, 1 is less than radical 3. So if you subtract radical 3 from 1, it's going to be a negative. And then here we get a positive. So this interval is positive. Now if you plug 2 in, again, you end up getting a negative for that one. Plugging 2 in here, 2 is bigger than radical 3, so you'd end up with a positive. And then plugging 2 in here, you get another positive. So this is a negative interval. Okay, now I'm going to do the acceleration. So acceleration at t is negative 60t squared plus 60. I'll take out a negative 60, t squared minus 1. Just to be consistent. You don't need, I don't know. Okay, and then negative 60, t plus 1, t minus 1. So similar situation here, guys. Time is starting at 0. All right. So the critical numbers for this factor, when you set it equal to 0, you get -1. We're not going to use that one because it's not within our, time interval. Here we get +1. So I'm going to put a +1. I don't know, I'll pick like a half, and I'll pick 2 again, I guess. Now this negative 60 here, that's always negative. So I'm going to have when I plug in a half, I'm going to have a negative, then I'm going to have a positive, and then I'm going to have a negative. So that's a positive interval. When I plug in 2, I'm going to have a negative, because it's always negative, and then a positive and a positive. So that'll be negative. Okay, now, okay, so the idea is this, guys. So let me do, now I'm going to do 2 number lines, okay? So for this number line here, I want v of t and a of t both positive, okay? And then over here, I want v of t and a of t both negative, all right? Because that's when the particle is going to be speeding up, when they have the same sign. Okay, so over here, I'm going to put all of my critical numbers here. So I've got, so one is from here. Okay, so this one goes right there. And then also radical 3. 1, radical 3. Okay, so both positive. So velocity is positive from here to here, and then right there, and then acceleration, no, I'm wrong. Velocity is positive from there to there, okay? And then acceleration is positive from there to there, all right? So you look for the overlap, okay, so right there. So here's the overlap. So it's going to be from 0 to 1, And then we're gonna maybe probably have a union, all right, because here's gonna be where they're both negative. Velocity is negative from here on, and acceleration is negative from there on. So the overlap, you know, is starting there. So it's going to be this union radical 3 to infinity. Okay, so make sure you practice at least a couple of those on Delta Math without a calculator. Okay, at least a couple, guys. You really want to be good at this. Okay, and it should feel, you know, you should feel confident that you can do it, and it should be like a pretty smooth process. All right, if it's not, that means you got to do more. So I'm going to do another video, but it's just 2 examples, and it will go much faster, guys. Okay.